Okay, we're going to specifically look at tan ratio. And there's technically three ratios. You have your sine ratio along with your cos ratio and tan, but we're going to focus on tan. We've been given a question with a bunch of info, and what we're going to do is make 3 different videos on this one, all using the same example, but talking about how one is better than the other. So tan is the TOA in that I did not make that an S. In the SOHCAHTOA, and it stands for TOA, right? The TOA stands for opposite over adjacent. So tan, and sometimes they use this theta, have you seen that before, to represent the angle, is equal to the opposite side of the triangle over the adjacent side. Okay, well, what they mean is the opposite of the triangle over the adjacent to this specific angle. So let's say we're working with this top triangle, and 27 is our specific angle. Okay, well then I would write tan, I guess we'll do it in red here, 27. 27 is equal to, I got to figure out what's opposite. What side is opposite of our 27 degrees?
A.
Yeah, that's our opposite. So it's kind of confusing because it's O and there's an A, but lowercase a, right? What is the adjacent side to that?
The base.
The base. And how long is the base?
200 meters.
200 meters. So it's 200 meters. So as long as we have, because there's 1, 2, 3, so that's 1, 2, 3 variables. As long as we have 2 out of 3, we can solve for the other. And we do. We got the angle, we got the adjacent, we can solve for A. So now we just kind of go through our BEDMAS. Now, technically, tan 27 is putting 27 into some very long equation that our calculators kind of do for us. So let's do that really quickly. I use this one because this one can work with degrees. 27 tan is 0.5095, okay? So 0.5095, okay, is equal to A over 200. Now to isolate for A, we would technically bring 200 over and multiply by it, right? So take that number in our calculator, times 200, 101.9. 101.9, and its meters is our A. Okay, so we've used tan to solve for this side, 101.9. Now, let's say I wanted to solve for, I'm going to use tan ratio again, so you can either solve for a side or you can solve for an angle. Now, there's technically 2 sides to solve for, but they're very similar. We're going to solve for the angle, which is a little different. We'll call this mu, okay, this little u thing, okay. It's going to represent that angle in there. Well, tan mu is equal to, what is opposite of mu in this case? What side is opposite of this u?
The 200 meters.
Yeah, the 200 meters is the opposite. So our opposite is 200 divided by, which is kind of opposite of the other one, right? What's our adjacent? What color event I use? Red. Okay, use some red here. What's adjacent to the mu?
A.
That's right, side A, which is technically, we just discovered 101.9. Now, I noticed that you never said adjacent this side here, and that's because that's the hypotenuse, and we don't really work with it at tan. Okay, well, the goal is to get mu by itself, and you can't technically divide by tan. You could almost think of that's like multiplication, but you can't technically divide really by tan. So when you bring tan to the other side, it becomes tan inverse, okay? So mu is equal to tan to the power of -1. And then in brackets, both of our numbers. Okay, 200 divided 101.9. So let's work this out, and that'll tell me what the angle is. So let's take our calculator out here. 200 divided by 101.9, okay, equals. And then here's tan, but I need tan inverse. So on my calculator, I have to hit shift, and then there's tan inverse. So I do tan inverse of that number, 63. So apparently mu is 63 degrees. So if that's the case, which it should be, this makes sense, right? If this is 90, these two, 27 and mu, have to equal 90. Well, 27 plus 63 gives us a 0 plus 1 is 90. Perfect, 2 90s, that's 180. So we know that that was right. So we used tan to solve for a side and for an angle.